In our next chapter, we are going to work with linear functions. We're going to start by learning a little bit about linear equations. A linear equation is the equation for a linear function. The reason why they are called linear has to do with what happens when we graph the function. If you look at the name, linear, you can see the word line in it. That is intentional because all linear functions, when you graph them, make a straight line. Since the linear equation is the equation for a linear function, linear equations will always form a line when graphed. And when we say line, we are assuming the mathematical or geometric definition of a line. The mathematical or geometric definition of a line is that it runs straight. If it doesn't run straight, we would usually call it a curve instead. So when we say line, we're assuming a straight line because that is the official math definition of a line. There are several different formats that a linear equation can take on for a linear function that we are going to learn about as we learn about linear functions. We're going to start with one of those types of equations so that you have something to look at to decide if you're looking at an equation, is this linear equation or is it something else? So one format that a linear equation can take on is what we call standard form. Standard form looks like this. A times x plus b times y equals c. Now there are a few rules. So first of all, notice there is an x and a y in here, and that's going to be very important. Any linear equation is going to have an x and a y in it because those are the pieces of the ordered pairs. If we're going to graph something, we need ordered pairs to put on the graph. So the x and the y in the equation are where the ordered pairs that we put on the graph come from. But that leaves us with, well, what about the a and the b and the c? So the x and the y, generally those variables stay in x and a y unless you're filling in an input or getting out an output to get your ordered pairs to graph. The a and the b and the c, however, should always be numbers. So a and b and c, there are some rules for a and b and c, what those should look like. So first of all, a and b and c should always be in standard form, correctly written, should be integers, which means no fractions. Integers can be positive or negative, but they are not fractions. There are also some other rules too. So they should be integers. They should also have a greatest common factor of 1. So basically that means that if a and b and c are numbers that are larger numbers and they can all be divided by the same thing, so if you can divide your entire equation by something, you should divide your equation and scale it down as small as possible. So that's basically what that's getting you to think about. So they should all be integers. They should all have a greatest common factor of 1. There is also a bonus rule, and this is a formatting rule to ensure that when somebody takes a linear equation and they write it in this format, that we're getting consistent answers. We're not getting different variations of things. So to help make sure we're getting consistent answers, a, so what that is, a is the coefficient of x. So whatever is with the x, that needs to be positive. If it's not positive, that's a pretty easy fix. You can just multiply your equation, multiply everything by -1, multiplication property of equality, or divide everything by -1 using the division property of equality, and it will flip things around to make that be positive like it needs to be. So if it's not quite in the format that it needs to be, then you can use your properties of equality, and you can use what we learned about working with equations in our last unit to manipulate the equation a little bit and make the format look right. C, notice there's no variable. So that is what we call a constant. So that will always just be a number sitting there. One thing that's important about this is A and B cannot both be 0. If they're both 0, then you would end up basically wiping out the entire left side of your equation, and your equation would fall apart, and we don't want that. So one of them could be 0. So if A is 0, you would still have the y part of the equation, or if b is 0, you would still have the x part of the equation, and that's okay. That's something that we're going to talk more about as we talk about linear functions, but you need to have something on both sides. So a and b cannot both be 0 at the same time, otherwise you're wiping out that whole left side of your equation. So a little bit thinking about standard form. So you can use standard form to check and see if something is a linear function or linear equation. And I want to show you an example of that so you can think about how can we use those things that we were just working with in our solving equations unit to help us see if something's a linear function. So I'm going to give you an equation. Y equals 1/2 x plus 1. We'll keep this very simple. So if this is a linear equation, then I should be able to take this equation and I should be able to put it in that standard form format, because we said that all linear equations can be written in that form. So that means we're going to have to draw on some things that we used in the last unit to see, well, can I make this equation look like that standard form outline to prove that it really is a linear equation? First of all, we're going to have to use a little bit of what we were working with literal equations, the end of the unit, to rearrange our equation. So in standard form, all the variables are on the same side of the equation together. So right now I have the x on one side and the y on the other side. So I need to move that over. So I can use the subtraction property of equality to take this entire term and move it over. So if I subtract that whole term from both sides, it's going to cancel it out here, and it's going to end up moving it over to the other side. Now I can't actually do y minus 1/2 x because those are not like terms, so I would have to leave it. Commutative property says that we can write this in any order. Y equals y plus negative 1/2 x or negative 1/2 x plus y. I'm going to put it negative 1/2 x plus y because that looks more like our standard form outline. So that looks kind of sort of like standard form. We've got the x and the y in the right places. We've got the constant, the c, in the right place. The only problem that we have is that we said a minute ago that in standard form, a and b and c have to be integers. So we have to say, okay, well, we've got all the things in the right places, but can we make all of those be integers to put it correctly into standard form? So again, we could use a property of equality. So the way that we could get rid of a 1/2 is by multiplying by the reciprocal. 1/2 times 2 is 1. That's an integer. But we also have to remember that that first number has to be positive, and right now it's negative. So we have to think, what can we multiply by that will make everything be integers? So we'll get rid of the fractions, and we'll make that first number be positive. So if we come through and we multiply by negative 2, that will solve our problem, because negative 1/2 times negative 2 is positive 1. So it would give us that. However, properties of equality say that if we're going to multiply one thing, we have to multiply everything, the whole equation. So that means that the y also has to get multiplied by negative 2. So it's going to turn into a minus, because positive times negative is negative, minus 2y. And the one on the other side also has to get multiplied by negative 2. 1 times negative 2 is negative 2. So now we can check this again. Say, okay, we have a and b on the left side together. We have c on the right side. Everything's integers. The greatest common factor of 1 and negative 2 is 1. So that means that that is in standard form, which means, yes, this original equation is a linear function because we can put it in that standard form format. So if you had an equation and you took it and tried to rearrange it and you couldn't get it to go in that format, then that tells you that it is not a linear function. So that's one thing you should be able to do, is put something into standard form to see, is it a linear function? There's one other thing that we're going to do in this lesson, and we're actually going to use the same equation, y equals 1/2 x plus 1, to talk about that. We talked about the fact that a linear equation is something that forms a line when graphed. So another way that you can check and see if something's linear is to actually graph it, or if you know something's linear, you can also graph it knowing it's going to make a straight line. There are two different ways that we're going to talk about that we can graph a linear equation. So we are going to, I will rewrite it so that we can make room on our screen. We're going to use this original equation that we started with. So we put this into standard form, and we'll put both versions of the equation just so we can have them both to work with. So same equation, we just turned it into standard form. We know that that is a linear equation because it goes into standard form. So there are two different ways that we could graph this. So one way is by using what we call intercepts. All linear equations, well, nearly all, most linear equations, if you extend the line far enough, at some point will cross over the x and the y axis on the graph. So those points where the line crosses over the x and the y axis, those have names. So the ordered pair where you are crossing over the x-axis, that's called the x-intercept, which makes sense if you think about it. Intercept means to meet up with. So it's where the line intercepts or meets up with the x-axis, where the name x-intercept comes from. Similar thing happens where the line crosses over the y-axis. So where it crosses or it meets up with the y-axis or intercepts the y-axis, we call that the y-intercept. Now, the reason we mention this is because it is a graphing strategy. So we have to think about what happens on the graph when you're on the x-axis or when you're on the y-axis. So I'm going to sketch a little graph down here just to get us thinking. So if we are on the x-axis, that means we are somewhere on this line. In order for an ordered pair to be on that line, it has to have, so it'll have an x-coordinate, whatever that x-coordinate is, 1 or 2 or 3 or -1 or -2 or -3. It'll have an x-coordinate, but the y-coordinate has to be 0 in order for anything to be on the x-axis. So basically, we're going side to side, but we're not going up and down to leave the x-axis. So the x-intercept, or the place where a line meets the x-axis, will always have a y-coordinate of 0. That's going to be very important and very convenient in just a minute. The opposite happens the other way. So where we cross the y-axis or where we meet the y-axis, that's going to put us on this line. In order for a point to be on the y-axis, we can't go side to side from the origin. We're just going straight up and down. So that coordinate, x would be 0 to show that we're not moving side to side, and y is going to be whatever it's going to be to move us up and down along that axis. So the y-intercept, because we're not moving side to side, x is going to be 0. One trick that I've told students in the past to help remember that, because students get confused with that, is when you're working with intercepts, the opposite of your intercept is 0. So the x-intercept, the opposite part of x is y. Y is 0. At the y-intercept, the opposite part of the y, which is the x, is 0. So if that helps you to remember that, then you can use that. Where this helps with graphing is that we can actually use the equation to figure out what the x and the y intercepts are so that we can take the equation and put it on a graph. The trick is to use this information, to use what we know happens at the intercepts to figure out what's going on. So for instance, we're going to get the x-intercept. We know that y has to be 0. So what we can do is say, okay, I know that part of the ordered pair, the y part is 0, so I can fill that into my equation. It doesn't matter which equation you fill it into. You're going to fill y into whichever version of the equation you want, and then solve for x, which is the other part of the ordered pair. I'm going to use the standard form equation just because it has whole numbers, and I think that whole numbers are a little bit easier for most people to work with. So I'm going to grab that equation, and I'm going to say, okay, so my equation is x, 1x, or x, minus 2y equals -2. But if we're trying to figure out the x-intercept, we know that the y-coordinate is 0, so we can go ahead and fill that into the equation. So x minus 2 times 0 equals 0. Now we can clean that up a little bit and solve. So 2 times 0 is 0. So x minus 0 is -2. Anything minus 0 or anything plus -0, 0 is not positive or negative, but anything minus 0 is itself, which means x is -2. So that means that the x-intercept for this graph is -2, 0. So we just found a point that we could use to graph this. Now we know that this is linear, so we know it's going to make a straight line. So in order to locate that line, we need at least 2 points. If we have just 1 point, our line could be going any direction. We know it's straight, but it can swing around any which way. So we need another point to anchor the line so that we know the exact location of the line, and then we can put it on the graph. So that's where we can find the y-intercept. So the y-intercept is another point that is a reliable point that we could find. So the y-intercept, we know that the x-coordinate is 0. So we can use the same process, the same idea, but now we can use it to find the y-intercept. So that was the x-intercept. So the y-intercept we know has an x-coordinate of 0. So we can come back to our equation and say, okay, so we're going to fill in a 0 for x because we know that the answer is going to be 0 something. And then solve our equation for y. So 0 minus 2y, basically just -2y. It makes a one-step equation. So we can come through with our properties of equality and figure out, okay, y must be 1. So that means that the y-intercept is going to be 0, 1. So now we could come and we could actually put that on our graph. So we could say, okay, the x-intercept's -2, 0, so it goes right here. The y-intercept is 0, 1, it goes right here. Since we already know that this is linear, we know it's going to make a straight line. So once we have the 2 points on the graph, we can go ahead and we can draw the line. And usually when we're working with linear functions, we will put arrows on the line basically to show that we could keep choosing inputs out this way, or we could choose, more inputs out into the negative. So this graph has what we call an infinite domain. Basically, there's no end to the inputs and the outputs of the graph. So we put an arrow on either end to show that it keeps going. And there are fractional coordinates in here. So you could fill a fraction into the equation. So there really are coordinates all along in here. So we want to show that. So that is one way that you can graph this. Another way that you could graph this is by making a table. So some people ask, well, why would I ever want to make a table? That's a lot of work if I could just find the x and y intercepts. A lot of people really like the x and y intercept strategy because it's really easy to drop a 0 into an equation and just solve the equation. Zeros tend to make things disappear, which makes it really easy to solve an equation quickly. The problem is some graphs might be straight lines, but they might have a couple of things happening. So you could have a situation where maybe your x or your y intercept is a really, really, really large number. So maybe you had something where Your y-intercept is 0, 4, but your x-intercept is, 150, 0. Well, that's going to be really awkward to graph because 150 is really far away from the origin. So that's going to make for a tricky graph. So you might not want to draw the line out far enough or draw the graph out far enough to show 150, 0. So that's one case where maybe you might want to use a table strategy we're going to talk about instead. The other reason why you might want to use the table strategy instead of the intercept strategy is if you have an x or a y-intercept that's not a whole number. So the last problem we looked at, we had what I call pretty x-intercepts and y-intercepts. We got nice integer answers that were easy to mark on the graph. Sometimes that doesn't happen. You might go to calculate an x-intercept or a y-intercept and you might get a really weird fraction. Maybe you get an x-intercept of something like 4/11 and 0. Okay, well, we can kind of estimate where to mark that on a graph and try and get as close as we can, but it's going to be really hard to graph that exactly accurately. So in that case, it might be better to make a table so that you can get some points that are marked accurately. So the table strategy involves making a table. We had a couple of different versions of our equation back up here. So this was our standard form version that we used to prove that this is a linear function. This other version that we started with, though, I intentionally started with because I wanted to use it to talk to you about the table strategy. In the last chapter, you learned how to rearrange or manipulate an equation when we were working with literal equations. So one thing that we learned is how to take an equation and solve it for a variable. So this starting equation that I gave you was the linear equation, but it had been solved for y, which is where we got the y equals 1/2 x plus 1. That actually is convenient when you're making a table because the table strategy involves choosing a bunch of inputs and then finding the matching output and putting it on the graph. So basically, make a table of inputs and calculate the matching output. So that's going to be a lot easier to do with this yellow highlighted equation. The standard form equation is actually going to get kind of annoying to do that with because every time you fill a number in for x in standard form, now you have to solve the equation for y. So if I go filling in a bunch of inputs, every single time I fill in a different input, I'm going to have to resolve the equation to figure out what y is. This yellow equation is a lot more convenient because y is already by itself. So when I drop an input in, I can just evaluate and it'll tell me the output rather than resolving the equation over and over again. So that's where some of that work you did with literal equations comes in handy. If you're doing a calculation over and over and over again, like solving for y, it might make sense to solve the literal equation or solve the starting equation for y to begin with, and then just drop the numbers in as you go. So with our equation, that might look something like this. I'm going to rewrite the equation to make it easier to see. Have x plus 1. So we can make a table, and we can just choose some numbers, some inputs to put in, inputs and outputs. So a lot of people like to use an input of 0 because 0 is easy to calculate with. So the input is going to go right there. So 1/2 times 0 is 0 plus 1 is 1. So that would give an output of 1. So that is a coordinate. It also happens to be our y-intercept that we can put on the graph. And then we can keep going and we can choose some other inputs. Now we can be smart about the inputs we choose to give ourselves things that are easy to graph. So we know we've got a fraction here, a 1/2. So I'm going to intentionally pick numbers that when I multiply them by 1/2 will give me a whole number answer, so that I have things that are easy to graph. So I probably want to stay away from odd numbers because odd numbers will not give me a whole number. So I could do something like 2. 1/2 times 2 is 1 plus 1 is 2. So there's another coordinate I could graph. I could go into the negatives, so you could go either direction with your graph. So I could pick a -2. 1/2 times -2 is -1, plus 1 is 0. That happens to be our x-intercept. I could choose 4. 1/2 times 4 is 2, plus 1 is 3. So I'm just using the equation and just dropping things in to the input right here to get the output. Once you get a bunch of coordinates, then you can take those and you can drop them on your graph. So 0, 1, 2, 2, -2, 0, 4, 3. And once you get a few of them, then you can see, oh, there's that straight line, and you can go ahead and draw the line. So that is a second strategy that you can use. And again, the reason why we have an alternate strategy is because while intercepts is fast and convenient for a lot of people, sometimes it gets messy if you have a really big number or if you have a really awkward fraction intercept. So that's where you might want to consider making a table instead. So that gives you an introduction to linear functions. So what a linear function or what a linear equation is, one way that we can write a linear equation. So if we can get it into that standard form format, that proves that it is linear. It will make a straight line when we graph it. And once we know it's linear, we have a couple of different strategies, intercepts or making a table, that we can use to actually graph that straight line.